everybody. The topic of this section is alternative discounted cash flow decision rules. In this section, we will discuss some discounted cash flow decision rules based on the compounded amount factor. Let's start with the problem. Suppose that a $100 saving bond maturing in 5 years is selling for a price of $75. Your next best alternative for investing is an 8% bank account. Compared to the bank account, is the savings bond a good investment? In this problem, we aim to know whether the savings bond is worthwhile to be invested. The interest rate in the alternative investment 8% is called as opportunity cost of capital. Formally, the opportunity cost of capital, also called as the market capitalization rate, is the interest rate that we could earn somewhere else if we did not invest it in the project under evaluation. Let's back to the problem. How to do the investment decision? The essential ideas are captured in the compound amount factor relating future value, present value, the interest rate, and the number of periods. That is, FV is equal to PV multiply 1 plus I to the nth. Given any three of the variables in this equation, we can find the fourth and formulate an investment decision rule based on it. In the first case, we use FV, I, and N to compute the PV. In this example, for the savings bond, its FV is $100 and its PV is $75. While for the bank account, FV is also $100. Interest rate I is 8% and the number of years N is 5. Using the formula, PV is equal to 100 over 1 plus 8% to the fifth. It's about $68.06. This means in order to get $100, we need to invest $68.06 into the bank account. But we should invest $75 to the savings bond. We can conclude that investing in the bond is not worthwhile. In order to simplify this comparison, net present value, or NPV in short, is defined as the difference between present value of all future cash inflows minus the present value of all current and future cash outflows. In this example, the present value of all future cash inflows is the PV of the bank account, $68.06. The present value of all current cash outflows is the PV of the bond, $75. And there is no future cash outflows in this example. Or more simply, the net present value NPV is equal to the PV of the alternative project minus the one of the project under evaluation. In summary, the NPV rule is referred, that is, accept a project if its NPV is positive, and reject a project if its NPV is negative. In this example, the NPV is equal to 68.0 minus 75 is near to the minus 7, so the NPV is negative, and investing in this bond is not worthwhile. Let's do a quiz. You have the opportunity to buy a piece of land for $10,000. You are sure that 5 years from now it will be worth $20,000. If you can earn 8% per year by investing your money in the bank, is this investment in the land worthwhile? For the land, its FV is $20,000 and PV is $10,000. In the bank, the FV is also $20,000. The interest rate I is 8%, and the number of years N is 5. By the formula, PV is equal to 20,000 over 1 plus 8% to the fifth is about $13,162. And then the net present value NPV is 13,162 minus 10,000 is 3,162. The NPV is positive, so investment in the land is worthwhile. That's all about the NPV rule. For this compound amount factor, we can consider in another way, using the PV, I, and N to compute the FV. Let's see the example about the savings bond again. For the savings bond, the PV is $75 and the FV is $100. For the bank account, the PV is also $75. I is 8% and the N is 5. By the formula, FV is equal to 75 multiply 1 plus 8% to the fifth is $110.2. This means with the same $75 cost, we can get $100 from the bond, whereas $110.2 from the bank account. So the savings bond is an inferior investment. This conclusion is consistent with that informal NPV rule. And this comparison between the FV is defined as future value rule. It says to invest in the project if its future value is greater than the future value that will obtain in the next best alternative. Let's redo the quiz about the investing in land again. For the land, the PV is $10,000, FV is $20,000. For the bank account, the PV is also $10,000. I is 8%, N is 5. By formula, the FV is equal to 10,000 multiply 1 plus 8% to the fifth is $14,693. So compared with the bank account, the investment in the island has greater future value. In conclusion, the investment in the land is worthwhile, and this conclusion is consistent with that of the NPV rule. For this compound amount factor, we can also use the FV, PV, and N to compute the I. Let's back to the savings bond. The FV is 100, PV is 75, and N is 5. Taking some algebra arguments to this formula, the I can be calculated as 100 over 75 to the 1/5, and then minus 1, which is 5.92%. This means the interest rate of the savings bond is 5.92%, while the interest rate of the bank account is 8%. Clearly, it is better to put the money in the bank. The interest rate I of the bond is defined as the internal rate of return, IRR, or yield to maturity, which is the discount rate that makes the present value of the future cash inflows equal to the present value of cash outflows. In this example, the IRR is the rate for the condition where the PV of the future cash inflows $100 is equal to the PV of the cash outflows $75. Considering the IRR, let's redo the quiz about investing in land again. For the land, the PV is $10,000, FV is $20,000, and N is 5. By the formula, the IRR is equal to 20,000 over 10,000 to the 1/5, and then minus 1 is 14.87%. This IRR is greater than the 8% in bank, so investment in the land is worthwhile. Up to now, we have compared the PV, FV, and I in this compound amount factor. The last variable, the number of years N, can also help us to make decisions. Let's calculate N for the bank account. In this example, we know that the FV is $100, PV is $75. The opportunity cost of capital is 8%. Then the N can be obtained by solving the equation 100 is equal to 75 multiply 1 plus 8% to the nth. We find that N is 3.74 years. It means that if we put the money into the bank with interest rate 8% per year, it would take 3.74 years for $75 to grow to $100. But with the saving bond, it takes 5 years for the $75 to grow to $100. So it is better to put the money into bank. And this comparison is defined as the payback rule, which means choose the investment alternative with the shortest payback period. In other words, choose the investment in which you can meet your growth goal, that is, turn the $75 investment into $100 in the shortest period of time. Comparing the number of years, let's redo the quiz about investing in land again. For the bank, the PV is $10,000, FV is $20,000, and I is 8%. And the number of years N can be obtained by solving the equation 20,000 is equal to 10,000 multiply 1 plus 8% to the nth. It is found that N is 9.01 years. It's longer than 5 years, so it is worth to invest in the land. In summary, in this section, we have studied 4 decision rules based on the 4 variables in the compound amount factor. The NPV rule from the PV, invest the projects with positive NPV. The future value rule from the FV, invest the project with greater FV. The IRR rule from the interest rate I, invest projects with greater I, and the payback rule from the number of years N, invest the projects with shorter payback period. However, the most common decision rule is the NPV rule, which is widely used and universally applicable. That's all about this section. Bye.